Now, how do we write a file? So we write to a file with a set of pixels, this grid of pixels, by using image.io.write, and this should be to file like this. Image.io write to file. And so actually, I'll just take this same exact code and I'm going to copy it. And I'll show you what it does, but I'll point out here first that we have our pixels. When we call write to file, we provide the name of the file that we're going to give as output, or a full path. So if you wanted to output to some folder, maybe a folder named output, you could have output/output_name.png. And I'll show you that in a second here. And then we pass in this list of pixels, two-dimensional list of pixels. So I'll go ahead and paste this in. We have our pixels. And then I'm going to do image.io.write to file. And the file that I already have created a folder here. I believe you have to have this folder already created. I made a folder called output. So I'll do output slash, maybe the name of some, I don't know, output1.png, and then pixels. So now, as I run this code, if I go over here, and we go and look inside of my output folder, there is now an image here, which is the exact image that I have defined. Now let's see a couple of other things that we can do. So to make this fully comprehensive, let's, instead of defining this, hard coding it, let's read in some pixels image.io.read file, and the file we're going to read is input/image.png. Right, and this will give us back some sort of pixels. And if we write this file, this will first read and then write. I have a typo here. Input. So as I write this, okay, input, output, it creates an output that looks the same as our input, which is great. But let's say we want to modify. So we want our output to look a little differently. Let's say we want to make the top left pixel, which in the input is yellow. Let's say we want to make it red. So first of all, what does a red pixel look like? So red pixel, it needs an R value, a G value, and a B value. So red, green, blue. So maximally red, the maximum intensity value for R is 255. For G, green, we want it to be not green at all and not blue at all. So it's only red. So that means that we're going to want to set the top left pixel to have a red value of 0, a green value of red value of 255, a green value of 0, and a blue value of 0. So we're going to get the top row, then the leftmost pixel in that row. So the pixel we're looking at is this one. And we want to make it red. So that means we want to set pixel 0 equal to 255, pixel 1, equal to 0, and pixel 2 equal to 0. And so the reason we're able to do this and we're able to assign into this pixel is because this is a list that is mutable. So that means that as we make changes, we read in this file and we make changes. When we write it out, those changes should be reflected. So if I run this now, run our code, you can see our input is here, our image input. Let's look at what our output looks like. Great. So our input was this file. We read it in. We got the top left pixel right here. So this was the pixel at location 0, 0. And then in that pixel, we made the red component. In this top left pixel, we made the red component maximally intense, and the green and blue components 0. So the pixel is only red. So this is the red, green, blue. And now when we wrote this out to our output image 1, we got this nice image where the top left pixel is changed from yellow to red. One more thing I'll show you is what if you wanted to get the width or the height of our image. Let's say we want to make a width or height. To get the width or height of our image, we can do that, get the width. The height first. So the height is the number of rows that we have. So the number of rows that we have is the length of our pixel array, because each entry in our list, right? Each entry in our list is one of the rows. So each entry here in the outer list is a row. So the height is the length of the pixels. Then the width is going to be the number of pixels per row. So if we grab one of the rows, maybe just the first row, the length of the row itself will give us the width of the image. So now when I run our code here, it tells us that the height of our image is 4 and the width is 3, which is correct. The height is 4 here and the width is 3 pixels. Now finally, I'm going to show you how to create a new image. Let's say you don't want to read something in, you want to start your own image. For that, you want to create kind of a blank canvas. So pixels starts off as empty. Whoops. And let's say that you want an image of width equals, I don't know. So the width is 10 and the height equals 5. So the height is 5, width is 10. So that means that we will have for, how many rows will we have if our height is 5? So if our range is going, we have one row per kind of count of the height. So, and I'll call this row index, range 10, and range 5. And then we need a nested loop here to get the column index in range, width. So actually, I'll just do it like this, using my variables here. So for each row index, we want to create a empty list. And for each column, we want to add 1 pixel to that list. So we'll do row.append. We'll do the pixel 0, 0, 0. And finally, after we're done filling in that row, we want to add it to our pixels, our entire image. So pixels.append row. So now after creating this, we should be able to see an image that is all black. We'll print out pixels. Let's just not write anything to the file right now. Let's run this and see what happens. So, okay, we got a whole bunch of zeros. Let's actually see what it looks like if we write this out. Whoops. If I do write this to memory. Okay, see, yes, so we have an image that's all black. All black isn't super fun, so why don't we actually make this a little bit more fun? Remember we learned about the import random module. And we learned about, so red, we learned about how to get a random integer. So we did rand range, starting from 0, going up to 256. This will select a random integer for red, for blue, and for RGB, like this, red, green, blue. And now we can use those for our color, our intensity values, red, green, blue. So let's see what this looks like. So now we have some nice random values. Let's look at our output. Ooh, that is much prettier. This rainbow image, and we can see that they're 5 pixels tall, so 5 rows, and each row has 10 pixels across. And the cool thing is, like, remember what this looks like. If I run this again, and let me change the file to be output2.png, this will generate a totally different image, which is really fun. So here's output 1, here's output 2. So see, they differ. Totally random colors, all pretty and fun.